Thursday. As you know, I'm not at school today, so I thought I'd make a little video of what you will be doing today. So you have a couple options, all right? Now, today we're going to be focusing on ionic bonds, and I introduced that to you yesterday with the different charges and how all the charges react to each other. So what we're going to do first is we're going to take a little bit of our day 2 notes, all right? I'm going to show you what they kind of look like, and I'm going to go a little quick. So if you ever need to pause the video, please pause the video.
Once again, a member of staff, we're attending the side.
Sorry about that. I had to pause it for their announcement on the speakers. So I'm going to show you our day 2 notes here real quick. All right, looks something like this. Okay, I'm going to pull myself out of the screen here, hopefully, if I can. All right. So day 2, chemical bonding, and what it looks like is we're going to talk first about properties of ionic. All right, now we're not so much focused on the properties today, but these will be very valuable to know in the future. All right, so properties. They're very strong. They're solids at room temperature. They have high melting points. So if you ever put it on like a Bunsen burner or something, it will take a lot of heat in order to make it melt. This is key. There's a metal and a non-metal. All right, there's always going to be a metal and a non-metal. All right, and it does not conduct electricity in a solid. However, it will conduct electricity when it's a liquid or aqueous. All right, so you might be wondering, what in the world is an aqueous? Well, an aqueous is whenever the solid is dissolved in a water. Okay, so let's say you take table salt and you stir it into water. That's an aqueous state. Okay, so those are just a couple background properties of ionic compounds. Okay, so let me show you some examples of the formation of compounds. Sodium and fluorine. So yesterday I showed some ideas of charges in sodium and fluorine. So sodium has how many dots? Has 1 dot. Fluorine has how many dots? Has 7. So you can either look at the dots or the charges. If you look at sodium, sodium has a +1 charge. Fluorine has a -1 charge. So if you're looking at this, how many of each of those will you need? Well, you'll only need 1 of each. So your formula would be NaF. That's your formula. Okay. The Na will transfer its electron to fluorine, and you only need 1 of those. All right, try this one out. If you need to pause the video, pause the video. I'm going to go over the answer. Magnesium and chlorine. You will need 1 magnesium and 2 chlorines to satisfy everything. MgCl2. You ready for a tough one? Here's a tough one. Aluminum and sulfur. If you need to pause the video, pause the video. I'm going to go over the answer. Wow, if you needed 2 aluminums and 3 sulfurs. Like I said, if you like the charges, go for the charges. If you like the dots, solve these questions doing the dots. All right, and that's it, everybody. We're going to have a couple practice. Here's a little. I forgot about the empirical. I'm sorry. Empirical is just reduced. All right. The chemical formula of an ionic compound is arranged in the smallest whole number ratio. Basically, it's just reduced. Okay. So if you have 6 over 4, you can divide each of those by 2, so you get 3 over 2. Good chemistry joke right there. If you can see, you probably can see the top. There's the top. There's the bottom. Anyway, so what we're going to do today is you have 2 options. One is the whodunit. We've done a whodunit where you have this paper. All right, you're going to walk around solving the mystery of the questions. There should be questions around the room. Solve those questions. Analyze whodunit. Once you have your guess, see your sub, they will have the answer. So, step 1, who done it? You can start any question you want. All right. Number 2 is a partner activity. What you have is this. And what you're going to do is you're going to roll 2 dice. Okay? And on this, there's a 5x5 grid. A 1, 2, 3, 4, 5. A 1, 2, 3, 4, 5. So if I roll 2 dice and I roll a 2 and a 1, what I can do is I can answer the 2 and 1 spot. Or I can answer this question. And each question, all it's asking is, all right, if you are given Ca and Cl, how many of each of those do you need to balance each other out? Like I said, you can do the charges or the dots. Your partner is going to see if you got it right or wrong. Right? So like I said, you could choose one of those 2 right there. Right? If you got it right, put your mark. Fantastic. I am circles. If you got it wrong, however, your partner steals that and can put their sign on that spot. And then it's your partner's turn to roll the dice. Let's say your partner rolls a 5-5. Well, they got to solve the question that is down there. All right? If they get it right, they can put their mark. If they get it wrong, you get to put your mark on it. And then you take turns going back and forth answering questions. The goal is tic-tac-toe, 3 in a row. If you roll a 6 is a wild. You can pick anywhere you want to go. Okay? So, a little fun tic-tac-toe determining how many of each element you need. Alright? So, hopefully that makes sense. If you have any questions, just let me know. Email me. I'll be close to my computer hopefully most of the day. So, hope you have a great day. See ya.